Hey guys, Miss Gill here with Chapter 2, Lesson 1. So in Chapter 2 we have 4 lessons. In the first lesson we are going to learn how to describe transformations of quadratic functions, learn how to graph transformation of quadratic functions, and write functions that represent transformation of quadratic functions. So you may feel like some of this is similar to something we learned in Chapter 1. Hopefully you do. This chapter is designed for just quadratic functions. So we're going to do some of the stuff we've learned, but now with quadratic functions instead of absolute value. So let's get into this. A quadratic function is a function that can be written in the form of f of x equals a times x minus h squared plus k, where a doesn't equal 0. The U-shaped graph of a quadratic function is called a parabola. All right, so now we're going to talk about translations when it comes to quadratic functions, very similar to what we have already talked about. Okay, so when we have a horizontal translation, it shifts to the left when h is less than 0. So you could also say when your inside is adding. All right, it shifts to the right when h is greater than 0. So this is the tricky part with this, though. I almost didn't want to put this on here, and somehow this should be right here. That should be too. I'll try to fix that in some of the copies, but I've already made some. Anyways, it's shifting to the left. I put this here just so you would remember that it's why does it say less than 0? Because remember, this is our formula. In our formula, x minus h, think about the whole reason it becomes plus is x minus a negative number would be x plus h. Okay, so again, if you've got the copy that doesn't have this fixed, I apologize, but that's where it's supposed to be. Vertical translation, so it shifts down when k is less than 0. So if you want to put subtract next to the side, you can. It shifts up when k is greater than 0. So when you're adding to the function. Okay. Reflections. So reflections in the x-axis flips over the x-axis and is represented by a negative output. So an example would be negative x squared, which is equivalent to negative x squared. So either one of those. All right, reflections in the y-axis flips over the y-axis and is represented by a negative input. X squared is its own reflection over the y-axis. So I'm going to put y right here. All right, so if we have a negative x and we square it, so this would be reflecting it over the y. Well, what is a negative times a negative? A positive. So those two are equivalent. And think about, we talked in Chapter 1 about absolute value functions and how when they flipped over, they didn't change if they were on the y-axis. So same idea. Quadratic functions are symmetric, so this one looks the same when you flip it this way. So if it's a u, when you flip it, it's still going to be a u. I know that was an ugly u, but whatever. Okay, moving on. Horizontal stretches and shrinks. All right. We're going to highlight this because we still have issues with this. Horizontal, remember to use the reciprocal and it affects the input. What is your input? X. Right? Vertical affects the output. What is your output? F of x. Or y. Those are the same thing. F of x and y is the same thing. All right, so it stretches away from the y-axis by a factor of when a is greater than 1. It shrinks toward the y-axis by a factor when a is between 0 and 1. Because remember, we're not talking about less than 1, because if it's negative, you're dealing with a reflection. All right, so if you need to, because some of us are still forgetting that reflections involve negatives. Anytime you got a negative, you're going right back to reflections. All right, so vertical is the easy one. You do not have to do the reciprocal. It affects the output. If it's a stretch, it's stretching away from the x-axis. And by a factor of a is greater than 1. That's how we know it's a stretch. It shrinks towards the x-axis by a factor of a when a is between 0 and 1. Again, not less than. So I do want to point something out, and if you want to talk about this in class, let me know, because a horizontal stretch, it's pulling it away from the y-axis, so it's stretching it this way, right? That looks the same as a vertical shrink. So visually, these two look the same. A vertical stretch and a horizontal shrink visually look the same. Just like a horizontal shrink and a vertical stretch, because you're shrinking it towards the graph, right? You're pushing it down, compressing it towards the y-axis. The vertical, you're stretching it up, and it does the same thing. So visually, these are the same. How do you know the difference? You have to look at the equation. So that's why it is important to know how a stretch and shrink affects your equation. So remember, with horizontal, you have f of a times x. With vertical, you have a times f of x, right? So a is being multiplied to just your x value with horizontal, and vertical is multiplying to the whole function. All right, so I know I took a little bit of time to talk about this, but I just want to make sure that we have a good understanding before we dive into these and start doing some problems. All right, so example 1. Describe the transformation of f of x squared represented by x plus 4 squared minus 1. So if we go back to our vertex form, we know that this is our h value, this is our k value. And I don't know why that was going to look like an h. But hopefully if you remember from chapter 1, we also know that this 4 means it's going that way because it's going opposite inside, and the 1 means it's going that way. So your vertex, right, because our vertex is hk, your vertex is found by doing the translations. All right, so because h is negative 4, it's going to the left, and the k is negative 1, it's going down. So we would say the graph of G is a translation 4 units left and 1 unit down. All right, so moving on. If you need to pause and write that, please do so. So example 2, describe the transformation of x squared represented by G. So we have this negative here, right? We said a negative means reflection. I'm just going to put REF for short. And then we have this 1/2. So it is being multiplied, and it is being multiplied to the function. Okay, we'll talk about in a second how to see the difference, okay? So it's being multiplied to the function, so it's between 0 and 1, so that means it would be a vertical shrink. I'm just going to put that for short, okay? That way if you want to write the sentence and move on, you can. So I'm just going to write that real quick. Okay, there we go. Sorry that I didn't give us much room to write that. Anyway, so looking at this one, notice how the 2 is inside. So the 2 is inside attached to the x. The square is outside. So because this 2 is inside, that is a horizontal movement. And guys, y'all don't have to circle these on your notes if you don't want to. I'm just doing it so you know exactly what I'm talking about. All right, so remember though, what was important about horizontal? We have to think about this in terms of the reciprocal. So what is the reciprocal of 2? If you said 1/2, you are correct. So this number here tells us if it was a horizontal stretch or a horizontal shrink. So because the reciprocal is 1/2, it is a shrink. Okay? I'll put an example over here in just a minute of the difference between the stretch and the shrink. Okay? So think of the reciprocal before you decide with horizontal. And then we know this +1 means it's going up 1 unit. So this is a horizontal shrink by a factor of 1/2, followed by translation 1 unit up. All right, so in your answer, when you're talking about stretches and shrinks, you need the factors, and in horizontals, your factor is the reciprocal. Okay, so over here in the side, I put 2 examples because vertical and horizontal is the most misunderstood concept in these lessons. So when it comes to quadratic functions, it is a vertical stretch. So if you want to put stretch out here, is a vertical stretch when it looks like this. So a vertical stretch by a factor of 2. Notice the 2 does not have the square attached to it, only the x does. It is a vertical shrink when it's a factor between 0 and 1. Again, notice that the x has the square, not the 1/2. So horizontal is different. This is a horizontal shrink. All right, remember I told you how vertical stretches and shrinks visually look the same? This is why the numbers have to use the reciprocal. All right, so this is a shrink by 1/2. Okay. Notice that the 2 and the x are inside the parentheses. The square is on the outside. Okay. This one is a stretch because, again, the stretch horizontal and the vertical shrink visually look the same. Or stretch horizontal, vertical shrink. Yeah. Yes. Okay. I was making sure. I didn't want to tell you the wrong thing. So stretch by a factor of 2. Here, I'll just put by 2. Okay, so when you're talking about horizontal stretches and shrinks, you have to use the reciprocal as their factor. And again, as always, if you have more questions on this, or you want maybe the translations, the reflections you're great at, but the stretching and shrinking, you're like, we can always practice just the stretching and shrinking. We don't have to talk about everything. All right, so if you want to practice some more of these, just let me know. Okay, so moving on to the next page. Example 3, describe the transformation from the graph of f to g. So here is the part that most people don't pay attention to. You have to see which one is f of x, which one is g of x. Okay, because on my paper, I have a colored version, but on yours, they're going to be both black or black-gray. Okay, so you have to look for that. You're being told to find from f to g. So we're looking from this black graph to the blue graph. Okay, many times I get the opposite answer because this part isn't paid attention to. So let's look for 2 that we could visually see is the same. All right, so for example, this left side of the black graph, the left side of the blue graph. So we see that it is moving this direction. Right? Again, we can see a point here and a point here, and is moving from black to blue, so it is going to the left. So the function g of x equals f of x minus h indicates that the graph of g is a horizontal translation of the graph of f. So the graph of g is a translation 3 units left of the graph of f. All right, so again, you're just visually looking at the graph. Make sure you're going to the right graphs and find common points. All right, most of the time they give you a clue. Like our clue was right here, x minus h. So we knew that was a horizontal transformation. All right, next example. Describe the transformation of f of x equals negative 2x squared plus x. What? Oh, yeah. Represented by g of x equals f of 0.5x plus 1. So this is kind of like, I think it was lesson 1.2, the lesson everybody hated, that this gave us our directions on this one. Like, we don't care where this one is. All right, we don't care where that one is. We're going to take this graph and we're going to move it again based on these directions. Okay, so you got to know how to find the direction. So the easiest direction that I bet all of you know is this one right here. You know that that means it goes up. I think most of us have that part down. All right, so what is this 0.5 being multiplied to just the x, right? Not the function, because if the 0.5 was out here, it would be the whole thing. So this is just the x. So 0.5 is the same as 1/2. Since it's inside with the x, that means it's a horizontal transformation. So it's being multiplied. We know it's a stretch or shrink. How do we determine? Well, 0.5 is the same thing as 1/2, right? What is the reciprocal of 1/2? 2. So is that a stretch or shrink? That is a stretch. All right, so the graph of G is a horizontal stretch by a factor of 2 and a vertical translation 1 unit up of the graph of F. All right, so this one I didn't put a table on here, but guys, remember when you're dealing with the tables, because I think you have one on your practice, the tables you're looking from f of x to g of x, so it's always a vertical transformation. All right, we're down to the end, writing a transformation of quadratic functions. So the lowest point on a parabola that opens up, or the highest point on a parabola that opens down, is the vertex. All right, so your maximum or minimum point is your vertex. The vertex form of a quadratic function is given to us right here, where a cannot equal 0 and the vertex is h comma k. So we'll say the vertex form. All right, so we're gonna fill in the spots here. So that way you guys, maybe it'll help you, all right? So if the A is in front, all right? If the A is in front, it indicates a reflection on the x-axis. It can also indicate a vertical stretch or shrink. How do we know it's a reflection? Because there would be a negative, right? So this H indicates a horizontal translation, right? If it's being added, we're going to the left. If it's being subtracted, we're going to the right. And then the K indicates a vertical translation. So you're going up or down. A reflection. Vertical stretch or shrink. Stretch if it's greater than 1. Shrink if it's between 0 and 1. The horizontal translation, just put a reminder here. If it's x minus h, you're going to the right. If it's x plus h, you're going to the left. And for the vertical one, if it's plus k, you're going up. If it's minus k, you're going down. So just a couple little reminders there. All right, example 5. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x equals x squared. Write a rule. Remember, this word just means equation. You're writing an equation, all right, for G, and identify the vertex. All right, so reflection on the x-axis. So this tells us that our A is negative, right? So the A value is negative. Then we have what? Followed by a translation 3 units down. So this is our K value. I feel like there was something else. Oh, it is right here. Vertical stretch by a factor of 2. Also your A value. Okay, so we know A is negative, the A value is 2, and then we have the K value. So do we have anything talking about going left or right? And we do not. So in this case, because it does not go left or right, our H value would be 0. So let's take this into our equation. So we have G of x equals A times x minus h squared plus k. So we said our k value is 3 units down, so minus 3. Let me lift this up just a little bit. All right, we said our a value is negative, and that number is 2, so our a is negative 2. And since we're not given an h value, that value is 0, since we're not told that it moves left or right. So I'm just going to bring the rest down. All right, so I didn't want to jump straight to the equation and you'd be like, Ms. Gill, what happened to the h? So that's why it's being a placeholder for now. So now we are going to simplify. All right, so x minus 0 is x. X squared is still x squared. So this becomes negative 2 times x squared minus 3. Now I'm just going to simplify this and just make it negative 2x squared minus 3. So if you ever have something that looks like it's in standard form but it's missing the b value, because remember that's ax squared plus bx plus c, that means that it did not have a horizontal translation. So now we have to also, what did the rest of it said, write a rule. So this is our rule, g of x is equal to negative 2x squared minus 3. So here's our rule. And then we have to state the vertex. So the vertex is, so this kind of helps with your vertex too if you put that 0 in the place. So is 0 comma negative 3. All right, so you could imagine like if you were to translate this, it would not go left or right, and then it would go down 3, and this is the point that it would land on. So your vertex is related to the translations. Okay. All right, so that is all for this lesson. The hardest part of this lesson is going to be that vertical and horizontal stretching and shrinking. I feel that the rest will not be that hard. So again, if you just are struggling with the horizontal and vertical stretching and shrinking, just come to me and say, hey, Ms. Gill, I got everything else. I just would like to do a couple more stretches and shrinks, and I got you. All right, we'll do that. All right, I will see you guys in class.